I will talk a little bit about face recognition in general and how this can be applied to the fields that you are active in, which is mainly ID document issuance. But I want to start with a brief overview of general applications for face recognition. Where can it be used? What kind of use cases do we have today? Where is it used? Which customers are using face recognition for different purposes, different application areas? And then I will focus on ID document issuance and show essentially two use cases or two applications for this area. One is the ID photo capturing, standard photo capturing and quality assurance of ID photos. And the second one is how can we use face recognition to prevent fraud in photo databases. So just a few words about our company. Cognitec calls themselves the face recognition company, and that's exactly what we do. It's very easy to describe what we do. Face recognition technology and applications based on that technology. We're based in Germany with subsidiaries in the United States and in Hong Kong. We call ourselves the face recognition company because, we are very much focused on that technology. Many people will say that they are a technology leader, but there is also some proof for us that we have indeed a leading algorithm, a leading technology. You may know that the American National Institute of Technology and of Standards and Technology is testing biometric algorithms every 4 years, fingerprint, iris, and face recognition as well. So we participated in that test for the first time in 2002, and were the first among all the participants right away, and were similarly successful in 2006 and in 2010. NIST is actually preparing a new test for this year, later this year, so we're looking forward to that test. In our industry, it's very important to participate to those tests. So if you look at comparing face recognition technologies, you will certainly go onto the website of NIST and can find all the results there, all the reports with company names and all the details. We started developing this technology actually as a team within Siemens in Germany in 1995, and later on in 2002 founded our own company, Cognitec. The main business channels that we use is working with systems integrators and value-added resellers. And you will find a number of them in the hall here, companies that have integrated some parts of our technology into their solutions and sell these solutions to their customers. So face recognition usually is part of a much more complex a system like an ID document issuance system, a border management system, a video surveillance systems, etc. So we work with these companies who integrate our technology into their solutions. So since 1993, we have been working on that technology. We have a very, the components of face recognition consist of a face finder and face tracker. If you come to our booth, you will see how this works. So tracking faces in video streams is a very important part of that technology. And the other component that is actually tested by NIST is the accuracy. I mean, whenever you talk about biometric solutions, in particular face recognition, the customer will ask you for the accuracy. How well is it working? How are the error rates? And that is exactly what NIST is testing, and we have a very good track record in these tests. Yeah, how does it work? I mean, it's not easy to describe this with one slide. I just want to do this. Face recognition is a complex technology, actually. If you compare it to fingerprint recognition, for example, you could say, or at least we say, that fingerprint recognition is trivial. I mean, you look for a couple of points on the finger and that's it. I mean, that's very easy from a technology point of view, from a pattern recognition point of view. But finding the typical or the characteristics in a face is much more complex. So what is characteristic in a face? And it's not easy to answer what it really is. You have some points like the eye positions and maybe the tip of the nose and the chin, but that's it. Everything else has to be extracted in a way of pattern recognition technology. And that's at least how our technology works. It's a very complex pattern recognition algorithm that extracts the characteristics of this face in order to recognize the same face under very different conditions. I mean, that's the art, to even recognize the same person under very much different conditions. This slide just shows the different tests that have been run by NIST and how our algorithm performed in these tests. And this just wants to show to you that that we invested a lot into R&D on these algorithms. The performance enhancement since 2002 was more than a factor of 20 for our technology. So I just wanted to show this to say that face recognition has indeed improved heavily during the last 10 years. And we are continuing researching on to find even better versions of the algorithms that we have. Okay, the market segments that we address with face recognition are listed here. The number one and the most important for us is definitely ID document issuance, with two applications that I will talk to in more detail in a minute: database search and photo acquisition. The second area listed here is border security. There are two different use cases for border security. One is compare the face of a passenger against a passport image, an image read from an e-passport, for example, to check if this is the person belonging to that passport. Right? So this is done in a lot of e-gates today. And if you look at those e-gates deployed in Europe, in the UK, and Germany, and Portugal, and Finland, and the Netherlands, they all use our face recognition matching algorithm in these e-gates. And this has become quite an interesting market segment, actually. The idea behind e-passports was exactly that you can use a digital passport photo read from the chip for verification of the person. And that's what an e-gate, what an e-passport e-gate does. Third area is law enforcement. Typical use case is that the law enforcement agency has a photograph of a suspect person or a video clip of a suspect person, wants to identify that person. So we supply tools to compare that photo against their criminal database in order to find matches in the database to identify the person, which is the same application that you use with fingerprint as well in an AFIS system. Fourth area is we call public and enterprise security. The main application is video surveillance, which means that you can identify persons from live video cameras by comparing all the faces seen against the blacklist photo database. And there are some commercial applications as well. In the meantime, I mean, at the moment, 95% of our business is in government and security, but there are a number of commercial applications coming up as well that are becoming more and more interesting for face recognition. If you're interested, I can talk about that in more detail later on. Okay, just a few examples on these applications. Border control, you see here a number of e-gates. On the right side, let's say a historic photo of a kiosk that we have deployed in 2002 at Sydney Airport, so-called Smart Gate. Was the very first e-gate, if you want, using face recognition at the time. On the left side, a number of gates, examples for modern e-gates like the ones in the UK or here in Portugal. Video screening, this is the application where you would identify faces from video streams. Just show a small video here that explains the principle. Faces becoming visible and get a certain size would be matched against the photo database. And on the right-hand side, you see the matches that occur. So the color photo is from the database that matched to some of the images grabbed from the video on the left side. Right? So do this again. And you can see a live demonstration of this application at our booth in this row here. Okay, so this could be used to generate some messages, like an email message, an SMS message, that would inform a security guard or somebody else who's interested in such matches. I'm okay. What? Oh, I have to close this. Okay. All right, thanks. So the typical application is a blacklist database, but you could also have a whitelist database in a, let's say, in a shopping mall where you want to inform registered customers when they enter the shopping mall. Law enforcement, yeah, this shows an example of a probe photo matched against a maybe large database. We have customers using tens of millions of photos in their criminal database, and the system would come up with a list of matches from that database. The police officer, the investigator, would look at these matches to prove that the person has been identified. Now let's turn to ID document issuance. The end customer segments are clear. I think all the government agencies dealing with ID documents, passports, national ID cards, Visa, driver's license.
Please can you collect your tickets from stand number 59. All inquiries related to Smart Card Awards, please visit number stand 59.
But also some commercial customers, of course, use ID documents like health cards or social security cards, corporate IDs that are in this segment. And the applications are the two that I already mentioned and that I will talk about a little bit more detail here. The so-called deduplication task for photo databases and the standardized photo capture. So the photo capturing, there are two parts. Capture a good photo that is suitable, for example, for an e-passport, and run a test against the captured photo that tells you, yes, this complies to the ISO standard, because that's what an e-passport photo has to be compliant to. So the product that we offer enables to streamline this photo capturing and the quality check of photos for ID documents. It checks compliance with ISO standards, or Kiosk standards, if some of them call them. But the standard that you check against can also be adapted. You can create your own standard if you want, if you don't have to comply to that international ISO standard. Take the picture quickly, link it to a database, a demographics database, and integrate. Integration is always a very important task for us. As I mentioned, we work with systems integrators who want to integrate our technology into their applications. So we are not only supply end customer products, but all our products come with an integration API so that you can create your own solution under your company name. Okay, let me skip this. Just want to mention that this product for photo capture and QA is currently the only product on the market that has got a government certification. We got this from the German government. The technology to check the quality of a photo is actually based on face recognition technology. It is not recognition in that sense, but of course we use pattern recognition technology to determine some of these quality metrics. Like we can check if on the photo the eyes are open, if the mouth is closed, if the person looks straight in the camera, or if it's a posed image. So this can be checked using very advanced pattern recognition algorithms. So these are some examples of the tests that we can run. Position of eye, ear, chin, and crown. This is used to correct the geometrics of the face in the image, head length and width. The lighting on such a photo must be uniform on the face. The background must be homogeneous. The exposure must be okay. It must be a sharp image, and the person has to look straight in the camera. It has to be a frontal pose picture. Eyes must be visible and open. Frontal gaze means that you're not only turning your head to the camera, but also your eyes look straight at the camera. You're not looking away with your eyes. This can also be tested. So this is called frontal gaze. The face does not move, the mouth is not open. We can check if the person wears glasses on that photo. We can also do things like estimate the age of the photo. This is not so much used for ID document issuance, but for different applications. For a given photo, we can estimate the age of the person, the gender, and the ethnicity using similar pattern recognition technologies. If you come to our booth, you can try it yourself, and we'll buy you a coffee if it's right. This is how the screen looks like. On the right-hand side, you see a lot of these tests that have been performed for this given photograph, and they are all green, so this photograph is compliant to that ISO standard. The quality check itself on a given photo is the one part of this system, of this product. The other part is capturing the photo. So we have integrated digital cameras into the product so that we can control the camera during the capturing process to make sure that the photo you take is already compliant to the standard. So this, as I said, this can be integrated into existing document issuance applications with the appropriate APIs. Can also be integrated in kiosk applications. We have some customers using kiosk systems to capture photos that they use, for example, on health cards. And we have an integration, an ActiveX component integration that allows to do this in a self-service environment in a kiosk with the same features that I mentioned. Camera recommendations. This is something that every customer has different opinions with. I mean, the recommendations that we give for passport photos is the type of cameras you see here. Yes, SLR cameras. I mean, they are simply the best cameras. They take the best pictures you can imagine. So this is in the range of $400, $500. For some customers with large deployments, this is sometimes too expensive. So, of course, you can also use lower quality cameras. We have integrated these other cameras as well, but we don't really recommend them for high-quality e-passport applications. Okay, the second job, as I mentioned, that you can use face recognition for is the deduplication task. And the product that we offer here allows to compare still images from different sources to very large databases of photos. We can do one-to-one comparison, of course, one-to-few, one-to-all, or all-to-all. All-to-all means that when we first install the system at a customer site, he usually has a database of photos already. The first thing to do is to check if that existing database includes duplicate images or not. So we can run the software against the whole database, and the software will come back and show you potential duplicates. And this has proven to be a very useful tool for the agency because usually they indeed find a lot of duplicates in their existing database that they were not aware of before. You know, if you enroll the same person under different names and they are in the database, there's no way to find them anymore unless you use face recognition, right? So we have examples for such a deduplication where like 10% of the images in the database were indeed duplicates for different reasons. Maybe fraud, but maybe also clerical errors. Somebody typed the name wrong or whatever and entered in the database, and nobody could find out anymore that this was really a duplicate. So whenever a new document is then issued, the new photograph would be compared to that database to make sure that that person is not yet in the database under a different name. Again, this is used for the different ID documents, of course. The result of of such a search in the database looks very much similar than what you have seen before under law enforcement. You have one probe image that you compare to your database, and you may find similars in the database. And in this case, indeed, the first and second on the match list is the same person. So then we have tools to do a more thorough side-by-side inspection of the photos to really prove that this is the face of the same person. These are two captured faces of the same person. Performance for this, yeah, we work with really large databases. The largest deployment we have at the moment is close to 100 photos in the database. It's a national ID project in a large country. So the focus for this product was really optimization for speed, for scalability, for upgradability, for high reliability, and that type of features. We can, in terms of speed, we can do about 1 million comparisons per second on one single CPU core. Which means that if you have a 20 million database, let's say, you can easily run identification against that database and get the results in a couple of seconds, which is required in document issuance, because document issuance is can be a high volume process where you produce thousands of documents every day. It's a client-server architecture. I don't want to go through this at the moment here. We support different operating systems here, different database systems that we can connect to. And again, we have an integrators SDK so that you as an integrator can integrate into maybe existing workflows or new workflows that are customer specific. Okay, so finally some examples of where one of these two products is in use for ID document issuance in the passport and national ID area, in the visa application area, and driver's licenses, mainly in the US, Canada, and Australia. Okay, that concludes my presentation. I wanted to show that, well, maybe I did not mention that, but we are convinced that the market for face recognition applications is actually growing very fast. We see a lot of demand for face recognition from the different application areas. We have indeed a world-leading technology. We have robust products that we have developed the last couple of years. We have strong partnerships. We have more than 120 value-added resellers that use our technology in their solutions, and an installed base worldwide in more than 100 countries.